Yeah. Today we'll talk something about very important, and in your book it's in chapter number 2. If you ask me, John, where is it? This is chapter number 2. Solution of equation in one variable. Solution in equation in one variable. Again, this is a little bit long, so excuse me. Focus with me about this one. Okay. What does that mean? Solution of equation in one variable. Solution for any equation like this equation or any other equation. Let's start with this one. For example, if I have this fx equal 2x for example, solution for this one, that we make this one to be 0. So 0 here means I want to find root. Root means here value of x. So solution for this one is find root. Root that you find value of x. So again, how we can find value of x? Either solve or you can find d f x or dy over dx and make it 0. So solution for the system at this point. This is the value for x. So what I'm talking about now is one variable or solution for one variable that we find root for this one. Okay, we can find root, we can solve the system easily. Yes, sometimes yes, you can, for example, df over dx equals 0 and solve it. It's easy. Sometimes it's hard. So today we'll start to study some methods to find root based on numerical analysis. So we'll start to talk about some methods to find root based on numerical analysis. And we don't have one method. We have, if you see the book here, we have 1, 2, 3, 4, 5, 6, 7, and more, I guess, 7 methods. We have to study bisection method, fixed point method, Newton method, and secant method. And if you have time, we'll study the error analysis for iterative methods. So we have many methods to study this one. And for each one, we have conditions. Can I use or no? For each one, there is there are many conditions. We have to work on it. So let's start about first lecture today. Root finding problem, as I told you. So now solving any system here, as I told you, that's mean find x for this one. Find x for this one. Or root finding a problem. Okay, let's start the first condition, and this is very important. This is the historical note, forget it. Now let's start talk about bisection method. By that mean dual or two sections method. That means we have two sections. We'll consider the section 1, and this is section 2. Wait, we'll talk about this in details. So what are the conditions for this one? Suppose a continuous function. So bisection is for continuous function. Can I use for discrete? No. It's defined on clause A, B. That's mean if I have, for example, function A and B both are included with given if A and if B positive. This is, for example, y, x, So I will explain more. Let's wait. This is, for example, A. This is B. So see if A is bigger than 0, if B less than 0. So if A and if B are opposite sign, so how many conditions we have? We do have 1, 2, and this is 3. So for bisection, before starting to say yes or no, you have to check these conditions. If one of these conditions are not correct or not specified, so you will cancel this method. You cannot use this method. How we will solve, I will tell you. Just a minute. So let's see here. I made assumption. Forget this. Okay. After got these conditions. So one condition, first one, second conditions, third conditions. Okay. Let's see some. Okay. And sometimes there are way or some formulas. Let's check these cases. Y, X. Okay. Again, conditions are first continuous for fx, second close A, close B, third if A dot if B less than 0. Why? Because if this should be positive, should be negative. Positive with negative usually gives to me negative. If both are positive or negative, that's mean not correct. Now let's check this. Is it correct or not? See here. This is discrete, so I cannot use bisection method. Second case. This A, B. Here in this case, here discrete. Here, if A dot if B bigger than 0 positive with positive. So also I cannot use bisection method. Third case, I have this function. This is A. This is B. Also I cannot, because we are dealing with open domain for last point. So also I cannot use bisection method. Last case, I need like something like continuous, either this or you can use this, also is correct. Close A, close B, if A, if B are negative. Multiply if A will be if B in negative, or A in positive, B in negative, or B in negative, A in positive, all are correct. Any question about this? Take care for these conditions. It's very, very important. Any question for this? Okay. Now let's continue with this one. How we can find the domain or solve. I will start with this. I don't need the geometric, but I will explain the idea. How we can find. We have this function, A and B. Let's check this function first of all. It's continuous. So here, if a or y is continuous, so the first condition is okay. Second thing, close A, close A, close, also correct. Third one, if A multiply if B less than 0. Yes, this is if A negative, if B positive less than 0. Yes, so it's correct. So here I can apply by section method. Okay, let's say this is the first domain, A1, A2. By that's me in the middle. So this is B1. B1 here is A1 positive B1 over 2. So this is the B. Make a line and stop here. Now, excuse me, focus with me, students. Here, I have 2 points in the positive, 1 point in the negative. So what I have to do, see my hand, change this point with this point in the second iteration. Keep this as it. Change this to be this. So again, what I did here, I changed the same sign. For example, middle point will be negative, so I will change negative with negative. Middle point will be positive, I will change positive with positive. So first point here is now was B1, now it's B2. Again, I will calculate midpoint B2. Now let's see the B2, where is it? It's negative. So this is the second iteration, B2 second iteration. B3, here I have 2 negative, negative with negative, and 1 positive. So what I have to do, change this with this, and keep this as it, and so on. After a while, after iteration, many iterations, we will arrive to this point. This point is solve for our problem. Solve for our problem. That means here is if x equals 0, we can find the value of x. This is B. So idea. First of all, check the conditions. Second thing, start to calculate. I will explain how we can make this, but this is idea. We'll start to find B. If B and, for example, A are same sign, change in the second iteration A with B, and keep B as it. P here, I'm talking about middle point. In the second iteration, now P and B in the same sign. Change P with B and keep A as it, and so on. So this is geometric explanation. Any question for this? Any question for this? Okay. I hope. Now, how we can solve this one? This is the code. If you want to write this code in one language, so I don't need, you can read at your home. Now, keep the error later. We'll talk about the error later. Now, let's see, for example, take this example. Solve if x equal cube x positive 4 square x minus 10 equal 0. First of all, we have three conditions. This fx is continuous. Yes, it's continuous. He told me has a root in the closed domain 1 and 2, so it's 1 and 2 closed domain. Use bisection method, determine, okay, an approximation to the root that accurate to at least within 10 exponential minus 4. What is this? How we can understand this word? He told me I need error from degree 10 exponential minus 4. That means I have to calculate errors, and this error should be 0 minus 4. It is 0 dot 1 2 3 4, then any number here. So minus 4, that means here I have to get four digit 0. Four-digit 0. Okay, so this is the meaning of 10 exponential minus 4. How we can start? Keep error. I will talk about error later. Okay. Before starting, I have to check the conditions. How we can check these conditions? Okay, we have three conditions. I will start with the first one. First condition is continuous. And it's polynomial, so it's continuous. He also told me it is closed domain. And in the question, he told me also closed domain. Now, I want to check the first one. If B should be less than 0. So let's calculate both if A, if B. A here is 1. So it is F1. 1 equal 1 positive 4 minus 10. It is minus 5. I will focus about sign. My eyes on the sign. Sign is negative. I don't care about the result. I need sign. Now if B, it is F2. Now it is 8 positive 4 with 4 minus 10. It is 2 exponential to 4. 4 with 4, it is 16. 8, 24. It is 14. And sign here is positive. So I have negative with positive. In this case, yes, I can use this method. Is it clear for you? Okay. Now, let's start with this one. Okay. I will make something like this table. After I check the conditions or this condition, we have to make table. In this table, we have you A, P, and B, and if A, you can add here column called FB, and FP, keep now error later. So we have 1 P, this is P here, it is A positive B over 2, and if A, if B, and B. Okay, how we can calculate this? We'll start with A. Now A is 1, 2, 2 positive 1, it's 3 over 2, it's 1.5. Now I will calculate. I will calculate if A1 here, it's minus 5. B1 it's 14. Now, if I calculate B, it's 2.375. Idea, I need sign. I need from you sign. So here it is. Give me the red one. Here is negative, positive, positive. Negative, positive, positive. So in the second iteration, make a line, what I have to do? See, negative, it is for A. So A enter as it, so it is 1. Second iteration. Now, I have P and B on the same sign. I will change B with B. See my hand, I will take this to be here. And I will calculate, now that we decided, I calculated this, I will start again with second iteration. Is it clear for you or repeat? See that clear? Okay, inshallah, I hope. Now, let's see in your book. In your book now, it is here 1.25. So, it is, if I calculate like your book, it is 1.25. Now, A is 1, so it's same. If A, it's minus 5. Here it is minus, so just a minute. What is it? You can calculate with calculator. It is minus 1.797, and this is B like B. So it's 2 point, so it's 14, sorry, 2.37. I will repeat again. I will see, I guess, more clear than here. Yes. FP, here it is 14 positive. This now it's B, so it's 2.3 positive. Now for third iteration, see my hand. I have A is negative, P is negative, and I have B is positive. So what I have to do here for third iteration, Sila, with me, excuse me. Negative with negative. I will change B with A. So now third iteration. I will change, see my hand, B to be here. And keep B as it. And calculate B again. It's clear for you. So if I have double sign, for example, minus, change B with B. If I have positive alone, keep alone. So in bisection, that means change same sign and keep the single sign alone. Is it clear? Is it clear for you? And you have to continue. Where I stop? He told me in the question, I need error 10 exponential minus 4. So I need error 10 exponential minus 4. See this 10 exponential minus 4, that means I need 1, 2, 3, 4 zeros. So this is the answer. I will calculate until this error. If I find this error, I will say this is my answer. 1.365112. 1.365112. If I want to check if my answer is correct, take this number and put in this formula if it's correct or not. For example, this calculator, this is a calculator. Yes. Just a minute. This is 1.36511 cube plus 4 multiply 1.36511 square minus 10 should be 0 or near of 0. See here, this is the answer. Minus if you entered inside, so it is 19463. So this is the answer. If I want to draw, for example, you can use some software to draw this one. Now I have a good question. Which error? You know we have two errors, absolute error and relative error. Which one you should use? Here in this, just in this method, write this in your notes. I have to use relative error. I have to use relative error. I have to use relative error. How we can do this? Okay. Let's start to calculate for first point and for others. For first point, it is a little bit relative. That's mean for first one, it is, this is the calculator. Like your calculator. This is like your calculator. In UP, it is this 1.5. Okay, make a fraction 1.5 minus A 1 over 1.5 equal. This is the answer. So for usually for relative error, it's in U. I will write here for you. Error here is in U minus old over in U. In U minus old over in U. So for first one, it is this minus this over this. This is for first one. For second one is this. In UB minus old P. Let's calculate together and find if it's okay or not. Here from the calculator. In UB here it's 1.2. Okay, make a fraction directly. 1.25 minus 1.5 over 1.25 equal. So here's the answer. 0.2. And again, use absolute value. Use absolute value. Use absolute value. In here, you have to use absolute value. So here, see, the error is 0.2. So for bisection, we have two ways to find error. For first error and for the following errors. Is it clear for you? Is it clear for you? Any question for this? So in bisection, if you see here, if you shall understand it, you are working with y and change in x. You will design, for example, you will find the sign from y, but you apply it for x. Is it clear? Yeah. Now, this is the explanation of this one. Now, I would ask myself a question, good question. Can I know how many iterations before it started? Yes. Break, continue or break, what do you want? Can you see the screen? Now. Okay. Now, can I know how many iterations before it started? Yes. Here we have a formula. This formula is really important for exam. Pn minus b, this is the error, less than or equal p minus a. Here, last boundary for this one minus a over 2 exponential. I want to find n. I need this n. How can I find this n? Okay, you can use this one, and here should n bigger than or equal to 1. But I will go directly with you to the last formula that you have to use in exam. Let's see the question here. Determine the number of iterations necessary to solve. And he asked me 10 exponential minus 3 using a1 and b1 equal 2. So how can I use this one? Here we have the final formula. So in exam, if you asked me about the last formula, this is the formula. N here is bigger than. In the question he asked me, see, I need error 10 exponential minus 3. So here I will write 3. N should be bigger than 3. But I will write the full formula. N bigger than 10 exponential minus, for example, x. So this is x here. Over log 10th to this constant. P minus a. P minus a. This is the last formula for exam. X here, this is x. This is constant. B here is 2 minus 1, so it is 1. Let's try. Here, for example, n here bigger than 996, so it's almost 10. The same formula. Let's see the answer in our book. Again, for the same formula here, error is 10 exponential minus 3. The same formula, we will find answer after 10 iteration. Let's see here in our question here. Okay, this table, minus 3. So see 1, 2, 3. How many iterations this is? Where is the full answer? This is the answer. This is the answer. Now, I want to find, for example, 0, 0, 0, 0. Again, I will write the formula with you. N should be bigger than. Here I need how many 0, 1, 2, 3, 4. So it's 4 over log 10 p minus a 2 minus 1. So it's 4 over log 2. As you see here, it's not related to the formula. It's just related to the a and b. Here formula is not included. Okay, let's check if it's correct or not. Okay, it is here 4 over. This is log 4, 2 close. It's 13.2, so it's 13. See here, it is 13. So here n is not related to the formula. It's related to the a and b. First and second boundaries for this formula. So this is important. Take care about this one. A here is not related to the a and b. Formula. It's just related to the a and b. A and b. A and b, not for the formula or formula. So what I have to study in exam, you have to know how to use this formula, and you have to know the first form. This one is very important. Again, if is continuous, closed domain, and if a, if b less than 0. So here we have 3 conditions for the formula. After that, you can use this formula. And this is how we can, here I know you can't find directly, but here's the last form that you can apply for this formula. Any question for this? So for n, I have 2 formulas, main formula and the last formula I can use in for this one. Okay, if I open your book, I guess I opened. Where is your book? Just a minute. Here, this one. If I go to the chapter number 2 and return back, Let's read your questions. Use bisection method to find B3. In exam, you have two ways for questions. First one, he asked me find just B3. So I have to calculate B3. Should he calculate error? No. In exam, he asked me just find B3. That's mean B3. But just find B3. Should I calculate error? No. And this is the formula. Another problem is x cosine x. In this way, go to calculator, shift, mod, change to radian, and work. This is the main mistake. Why? Because if I have this formula, for example, I have x minus cosine x. If I have from 0 to 1, 0 here is not like 0 here. If here, for example, if I have by here is different than by here. Here by it's 180, here's by it's 3.14. So for that reason, convert from degree to radian. Here, this is for cosine. So for exam, you have either he asked you find B3 or for B4, B1 anyway, or he will ask you about, for example, let's this by section find B3. Here he asked me find error 10 exponential minus 2. So that's another form. Here you have to calculate. Here you have to calculate relative error as I explained during the lecture. So take care about this. Here we have many questions. You can solve this question. For example, for like this formula here, you have two questions. This is the first question, and this is the second question. So excuse me, in exam you are responsible for 1, 2, 3, 4, 5, 6. Try to solve and give me the answer. By the way, there is a sheeting for you. What is this? Okay, close this. Here you can find by section calculator. You can, for example, find by section calculator, and you can use this one to solve your answer if you want. For example, find. Then another part, but here you have to stop. If you have add block, you have to stop add block, and you can find the answer for this one. So here, this is very good website, A to Z math. You can find what you want to find. I see. Okay, they stop because I'm using add block. Any question for this today? Is easy for you? Is it easy for you? Is it easy for you? Excuse me. Go home, Sila, Khalid, and solve this example. And this website can help you, but you have to stop the add block if you have add block. And to example, this is root from 2. And so you can find step by step. So this is, instead of don't ask anybody. This is the website is helping. Take care for yourself. Next week, inshallah, we'll start it with another one called fixed point method. Inshallah, will be easy. Have a nice day. Take care for yourself. Bye-bye.